Hello, my friends. Today I am at MedTech Industries here in Southern California, and you're in luck for many reasons. One, my voice is about done, so you don't have to hear me talk so much. And we got Rad Rob right inside. Two, we're gonna talk Kitamura. And three, if you notice, how the heck did they get a machine in this room? We're gonna find out today. Come join me. Well, we've made it inside the room, my friends. I'm with Rad Rob here, and we're gonna talk about this Kitamura. But a lot of times I like to talk about the machine's capabilities, describe to you about the programming, the software, the palette change, the accuracy. But today, we're gonna talk about this part. The reason I wanna talk about this part today is because it's gonna do everything we just described, but by showcasing to you guys the amount of precision that's here at MedTech Industries. So Rad Rob, let's talk about this part. Go into the detail of how many times, let's say, that we had to revamp, fix, reprogram. The tolerances are super tight on this thing, isn't it?
It's got a couple of really tight tolerances on it. We've been developing this part for probably 2.5 years now. And we've had probably 200 or 300 revisions of this part. And it's tweaking things here and there, a little bit this, a little bit of that. But it's got a lot of tight tolerances on it, really tight surface requirements too for surface finishes and things like that. But yeah, this machine's doing it no problem. It slides out. So
it's important to understand because not all machines out there can work in the world of Micron.
Correct.
And when we're looking at this part, we're talking about Micron, from one side to the other side on a bunch of different areas. And we're standing in the room right now where it's obviously temperature controlled.
Correct, yeah.
Because everything has to be perfect.
Yep.
With this machine, difficulties go down, but in general, that type of precision does create complexities in the overall situation of making the part, doesn't it?
Yep, sure does. And so like you said, big part of that is temperature control in the room. So as you can see, we've built a room around this. We've got a split unit in here to control the temperature. Our inspection room where we've got our Zeiss Micura, we're actually controlling that room at the same temperature that we're machining this at. We've got a coolant chiller on it. We've got mist collectors in here. We've got kind of the best possible shot at doing this on top of the Rego-Fix power grip holders that we're using in this machine as well. You get the total indicated run out of like a shrink fit with the speed and accuracy of it. It's been a great game changer for us almost. So between the machine and the tooling that we're using and kind of the process that we built around this part, it's been doing pretty good. So.
One thing I like about you, Rob, is that you're apparently a mind reader as well, because what I was going to talk about is one of my pet peeves that I have is when somebody invests in a machine like this, the quality that goes into Kitamura, and then slacking on some of the tooling that goes into it. The next question I want to ask you, I told you were good at this. The next question I want to ask you is, have you ever had frustration trying to make a part like this or this part on another machine? And don't get me wrong, I know some engineers out there love the test of taking a Micron part and doing it on a machine that's just not worthy of the part itself, right? Have you ever had frustration trying to do that as well?
Oh yeah. And in fact, that's actually what drove us to buy this machine was we've attempted it on other equipment and we just haven't had great success with it. And so we ended up with this machine, our MedCenter, with the 24 station pallet pool on it. I know we'll get to that in a little bit, but yeah, buying a machine and investing in the tooling and all that to make this part. It was a lot of frustration and it was a pretty substantial investment into getting to this point. But now that we're here, it's running them lights out. We can run this thing 24 hours a day, 7 days a week, no problem at all.
And to be fair, you said we're gonna get to it and we are, here we are by the way.
Yeah.
You say we're running it 24 hours a day, 7 days a week, but I've looked at this machine, I've looked at your tool holders, I've looked at your pallet changes. You have capacity for growth even. You're not even maximizing all of its potential.
Right, yeah, and right now, so the system that this part goes into, this part currently is running a lot faster than we have some other parts, like a big housing that this whole thing goes in. Right now, that's the longest lead time of machining parts, so right now this is already machining faster than that. So there's no need for us to go faster yet, but we're getting to that point, and we'll cross that bridge when we get there. Process improvement, making things better as we go, and faster and more efficient. That's what we're always after.
Oh, and you're doing it. You're absolutely doing it. And so I want to go back to this part, show the audience a little bit about what this part looks like. We're going to take a quick pause, not in the video, but for you guys to take a guess. I want you to leave it in the comments as well. You look at this complicated part. How many ops do you think it takes to make this part? Now, we are talking Kitamura, we are talking 5-axis, we are talking MedCenter, so maybe that'll help you a little bit, but when we talk about complications, microns, how many operations? All right, I gave you 3 seconds. What was your guess? Rob, what is the answer?
Two operations.
2 operations to get all of this done.
Correct, yep. Yeah, so we machine the bulk of it in this orientation here. And then we've got a little tab that just kind of hangs on to the entire part. And then we've got a second operation that runs on a different machine. It's not very accurate for Op2, but put a couple glue holes in, machine the tab off. That's pretty much it. So Op2 runs for about, I think, 12 seconds. It's pretty fast.
Now, I've run similar parts, obviously not this part, but similar parts with multiple operations where something like this would take me 5 machines, maybe 5 setups. Have you tried to run this? I don't think you'd be able to do it, would you?
No.
With the accuracies required.
Yeah, no, and on top of that too, a lot of it is driven by the accuracy, right? Like obviously a lot of these datum structures, the way I want to machine them, I want to machine as much as I possibly can in one operation, especially with a machine this accurate, because when this thing rotates, I know it's going to go exactly where I need it to go. So I try to machine as much as I can in one operation, and then the second operation, like I said, nothing's tight on it. The tolerances are wide open on the Op2 side of that, so we just run on a separate machine, a little 3-axis machine to do it pretty quick, and we can kind of batch them in big volume and just knock them all out in about an hour. So that goes a lot faster. But yeah, we've spent a lot of time developing the process for this part, and you know, after staring at this part for a couple of years and making hundreds of these, you know, you kind of get pigeonholed, and this is the way I've been doing it since day one. But figuring that out from day one, you know, I spent a lot of time, well, if I did it this way, but then it causes this problem, and if we do it this way, you know, kind of working through all your problems. And then when we landed on this method, it's just been working. So we haven't changed it since. The engineers have made revisions to it. Once we got the machine that could hold the tighter tolerances, the tolerances got even tighter than what they were originally based on the equipment we're machining it on previously. So now the tolerances are tighter, but this machine just had no problem at all. It hits it. It doesn't even blink an eye at it. You know, if I tell this thing to cut or comp 10 microns, it moves 10 microns. It's incredible.
Yeah, incredible is the right word.
Yeah.
And I'm not gonna make you say it because you've already pretty much said it, but guys, gals out there that are running machine shops, Rob said it in a way that matters, where he's able to do parts that might not have been able to be done in another method. You can get more work into your facilities by investing in machines like Kitamura. All right, last question I have for you, Rob. We're standing in a room. It's how we started off this video, but we're standing in a room. I don't see an exit strategy for this machine. If you're ever gonna move it, you're gonna have to knock down a wall. Did you literally build the walls around this machine in order to give? Did you really?
Did, yeah. In fact, when we moved into this building about 2 years ago, none of this was here. So this is actually the first piece of equipment that got brought into the building. I have a picture of it. Actually, I'll send it to you, of this machine sitting in a barren warehouse. Nothing else here, and then we built all the walls around it, put the drywall up, all the lighting in. The mist collector is actually above the room, so it pulls the mist straight up through the floor. Otherwise, you have that pump sitting in this room, and it's just a lot of noise between the spindle and the coolant chiller and all that. But yeah, so if this machine ever needs to leave here, that wall's gonna go.
Rob, you are a pleasure.
Yeah.
Rad Rob on Instagram, check him out. Check out MedTech Industries. They're making some really high quality parts. And check out Kitamura. Maybe they'll help you do something that you can't currently do in-house. Well, that was incredible, and it really brings to light what a Kitamura can do for you, right? But on top of that, it's important to understand that Kitamuras are kind of like Legos. So while this med center was already purchased with a pallet change and tooling options, you can add on to that in the field. So you can start with the machine as an original investment and then add tool change, add pallet change, grow it within a field, spread a little water on it, grow it like a chia pet. Oh my gosh, there's another Kitamura supercell over here. We gotta make a video about that. Oh, smelly cat, what are they feeding you?